Hey CS1B students, so as I've discussed in class, we've got this odd topic -1 because as programmers we tend to start counting from 0, so we've got a topic 0, but this topic underlies all of the topics that we have in CS1B, so I'm calling it topic -1. And it's this idea of a conceptual model, which I've discussed in class, in particular a conceptual model of the CPU. So what I'm describing to you now are the inner workings of this little thing, which you can't see in silhouette, but what some people refer to as a central processing unit, and as I've introduced the concept in this class, other names for this thing might be a universal Turing machine or a von Neumann machine and so on. But I'm just going to call it the CPU. And the CPU has these basic fundamental components or units associated with it. 4 basic units. And you can view these units in a number of different ways. They don't have to be viewed as a substrate on silicon using electronic technology. For example, there's an I/O component. That is a component of the CPU that allows it to communicate with the outside world. Note, that's really important, because it doesn't really matter what happens within this piece of silicon. If I can't get that information into and out of the unit, the whole machine is useless. So we can view this, for example, as mail slots. And I can view these mail slots as receiving or sending, say, 3x5 cards, paper cards, that come into and go out of the machine. Well, I have to have some place to store those cards, so how about mail slots? This is a conceptual model of a main memory. You can view each of these as holding, say, 8 bits of data. That's a convenient unit. And the way this machine is built, I have to be able to perform simple arithmetic and logical operations. And so an old-style adding machine would suffice to perform those kinds of operations. But the thing that ties this all together is the so-called program control unit. So that's this guy over here who is managing everything that happens within this machine. Now, we'll take a few minutes to walk through this model in class, but fundamentally the way it works is this. This box is sitting in a, quote, quiescent state. Nothing is happening. This guy is asleep until a button is pressed. And when a button is pressed, this guy reaches over to mailbox 0 and pulls out of mailbox 0 a card. And on that card is written an instruction. There are a certain basic set of instructions that he understands. They're built into this machine. And in fact, you could build different versions of this machine with different so-called instruction sets. But for the sake of our classroom illustration, we're going to assume a very, very simple instruction set. So this guy walks over, pulls out that card, reads what's on that card, and performs that instruction. And unless he's given any different instructions, when he performs that instruction, he'll go on to the instruction in mailbox. If we started with mailbox 0, the next instruction would be in mailbox 1, then he'll go to mailbox 2, then he'll go to mailbox 3, then he'll go to mailbox 4, and on and on and on, simply performing these basic instructions. The instructions on these cards are his program. He's the program control unit. The program is stored in these mailboxes. This is a stored program computer. Some of these instructions might direct him to do input and output, to get and to put. If there's a get, he'll walk over to this mail slot and pull out whatever card is waiting there. If it's a put, he might take a card and push it through this mail slot. That's how we're communicating with the outside world. Some of the instructions he follows might direct him to enter information into the arithmetic logic unit and then take information, view this as a card printer, and put that information into other mailboxes. So you see I'm storing information, that is data, in the same memory as I'm storing programs. We'll walk through an example of this in class, but this very, very simple architecture turns out to be very powerful. All of the concepts that we introduce in CS1B, all of the skills that we will be developing in writing C++ computer programs, everything at its core ultimately distills down to this very basic, simple, conceptual model of a CPU. It's really amazing that a machine which is as powerful, as ubiquitous, as world-changing as this device fundamentally boils down to this very, very simple conceptual model. Now, one of the things I'd like to ask you to do is look at the terms on this page and relate these terms to that conceptual model. Some of these we've talked about in class or will talk about. Easy ones like, what's a binary representation? More importantly, what's the difference between a machine language and an assembly language and a programming language, or a so-called high-level language? What's the difference between an assembler and a compiler? What's an operating system? What's a user interface? What's an application program or a development environment? You should be able to informally define all of these related concepts and point to somewhere in this conceptual model to explain them. If you can do that, I think you've learned a lot from topic -1. Good luck.